Yes, like full steez. We go run now, no worry. We go run
Yo, Tweezy, what's up?
What is this one?
Class, this is another STEM communication class. We are looking at the part 2 of algebraic expansion. You will recall that in the part 1 video production under this particular topic, we looked at so many preambles, up to about 7 or 8 preambles, before we looked into expansion in part 1. Those preambles are the foundation to mathematics. So I will encourage you, before you watch this particular video, go to search for part 1 of algebraic expansion in my YouTube channel at TSP STEM Resources, at TSP STEM Resources. Okay? Now today we are looking at the part 2. Now the part 2 is a bit advanced, because if you look at part 1, we're either multiplying something like maybe 1 plus x multiplied by maybe x plus 2, or we are multiplying something like x minus 9 squared, or n plus 10 squared. We did something like this in part 1, where the highest power, the exponent, is 2. Okay, what happens if you have x minus 9 raised to power 3, or raised to power 4, or even raised to power 20? Don't forget that x minus 9 raised to power 2 means x minus 9 times x minus 9. But if you don't have x minus 9 raised to power 20, that becomes cumbersome. It becomes tedious. It means x minus 9 times x minus 9 times x, how many places? 20 places. And in that one, if you spend even 20 hours, you will still be on it. And you will like the possibility that you make mistake is there. Is that clear? So that is why I want to introduce you to this method. So it is a bit advanced. Algebraic expansion is a topic that is being captured in GSS2, Junior High School 2 curriculum. Then it's in SS1, SS3, and so on and so forth. So the highest power you will come across at that level, GSS2, is exponent of 2. Okay? Now, the advanced aspect of this topic, for those of you that are preparing for exam like maybe Cowbell, Olympiad, and so on and so forth, then the question now happens that what happens if the power is now more than 2, if the exponent is more than 2? Then we need to deploy use of Pascal triangle. What I call it? Pascal triangle. Pascal triangle. We deploy it in algebraic what? Expansion for exponents that are more than 2. Is that clear? So the question now is this. What is Pascal triangle and what is it used for? Okay? So, right, Pascal triangle, look at it, these 3 silent figure means triangle. Pascal triangle is used to generate algebraic expansion coefficient. Algebraic expansion coefficient. Hello? Pascal triangle is used to generate algebraic expansion coefficient. You remember coefficient? If I have something like 3x squared minus 4x plus 1. The coefficient are the value you have before algebra. The value you have before this. Like this one I told you, since this is in terms of x, that means there is x power what? 0. So the coefficient is what you have before this. That is okay. So it means that in algebraic expansion of exponent greater than 2, Pascal triangle help us to generate either holistically or partially the coefficient. Exactly. It can be whole, it can be partial. Assistance in generating the coefficient. Now, how do you create Pascal triangle? I need to teach you that. Creating or generating Pascal what? I will teach you a method. Look at the method. Now, you will start like this with 1. Then you come down. Maybe you can even have a line. Okay, let me do it like this. Let me have some lines like this. Have some lines like this. It's better for you like this at your level. So I don't mess it up. Now, look here. You draw some line like this. I want to create Pascal triangle. I will start with 1 for the first line, okay? The second line, I will come here, 1. I will come to the other side of this 1 also. Do you understand that? Do you see that? This one is at the middle. The upper one is at the middle of this one and this one. Right? Then I will come here. I will start with another one here. Now, you add this together. What is 1 plus 1? At the middle, down 2. Then it ends with what? It will end with what? 1. Then again, I will start here again. This is 1 again. Always begin with 1 and it will end with 1. I'll start with another one here. Do you see that? Now what is it? 1 plus 2 is what? 3. You put at the middle of this down. Do you see that? Look at this. What is 2 plus 1?
3.
At the middle, just at the middle, 3 down. Then it ends with 1. Do you understand that? Then the next line, I will start with 1. Look here, you start with 1. What is 1 plus 3? At the middle, you put 4. Look at this one. What is 3 plus 3? At the middle, down, you put 6. This one, what is 3 plus 1? At the middle, you put 4. Then it ends with 1. Then you continue. Let me clean this. Hello? You cannot continue. Can you not tell me the next one now if there's another line here? You start with, I will start with 1. Hello? I will start with 1. 1 plus 4. 5. You put at the middle 5. 4 plus 6. 10. 6 plus 4. 10. 4 plus 1. 5. Then it ends with what? 1. Now, do you understand that? This one, the first one is when n raised to the power 0. This one is when n, the power, the exponent, I'll tell you the meaning of n, is equal to what? 1. This is when you have a plus b raised to the power n. Okay? This one is when n raised to the power what? 2. What will be this one now? N is what? N is power what? 3. The next one will not be what? When n is 4. And this one is what? N is 5. Okay? Now, take note of this. I want to clean this because I'm going somewhere. Just take note of that, okay? Now, so Pascal triangle help us in creating coefficient. The reason why I tell you is that I'm going to make reference to that. Now, let's see this. Let's say you are asked to expand this. If I say to expand 1 plus x raised to the power 2. Now, I will use the method we use in part 1 of this topic. Hello? If I say to expand this, okay? Now, the meaning of this is that this is as good as saying a plus b raised to the power 2. Because there are two terms there. So a is 1, b is what? X. Is that clear? Now, in the previous method, what is the meaning of 1 plus x squared? You know it means 1 plus x times 1 plus x. Do you agree with me? If you expand, you use this to multiply this. Is that also? Meaning you pick 1 into 1 plus what? Then you pick this x into what? 1 plus what? Is that also? Then let's open the bracket. 1 times 1, 1. 1 times x plus x. Plus x times 1 plus this s. 1s plus 1s. That will be 2 what? 2 what? 2x. Then plus what? F squared. Is that also? Is that also? Now let's use Pascal triangle to solve this same problem. What is the highest exponent here? 2. Okay, so that means I will create my Pascal triangle until I get to 2. The first one is 1 when n, this power, this is n, this is n, that exponent is n. Is that clear? Then the next one will be 1, you remember 1 and what? When n is 1, then when n is 2, this you start with 1. Hello? What do you do here? You add this together. What is 1 plus 1? 2. Then you turn it what? Now this is what we need. This is when n is equal to 2. So this is the coefficient. Is that clear? So look up. You will now use this one. You put 1. Then open bracket. You put a and b. Plus you pick 2. Hello? You put a and what? B plus, you pick 1, this one, then you put this A and this B. Is that clear? A and B, A and B. So this is coefficient. It's contribute to the coefficient I'm going to get at the end of the day. Is that clear? Now, this is 1, A, B. What is the highest power of exponent here? 2. So the first one, look up, you raise it to the power of what? Then this one will be, this one will reduce by 1, this one will be increasing, this one will be reducing. So from 2, what are you going to have here? A raised by what now? It reduces from 2 to 1. This one will increase by 1. That's what? B raised by what? You know 1 plus 1 is still giving us 2, right? Plus we have 1 here, this one. This is a raised to the power. This one will be reducing. From 1 it will reduce to 0. Is that also? Then this b will be what? It will increase. That's to 2. Is that also? You understand? Now, from this, if you compare this with this, you can see that your a is 1. Do you agree with that? What is your b? B is what? A is 1, B is what? X. Is that not? Is that not? So wherever you see A, you put 1 there. So this will be 1 bracket raised to the power 2. B is X raised to the power 0. Plus this is 2. A is 1 raised to the power 1. B is X raised to the power 1. Plus 1, A is 1 raised to the power 0, B is x raised to the power 2. Do you understand that? You now substitute. Now, this one is one term, another term. So we have 3 terms. Now look here. What is x raised to the power 0? X raised to the power 0 is 1. X raised to the power 0 is 1. So 1 raised to power 2, 1 times 1, that is 1. Times this one, everything here is 1. I take it again. What is 1 raised to power 2? 1. Because 1 times 1. 1 raised to power 2 means 1 times 1. Is that also? What is x raised to power 0? N raised to power 0 is what? 1. So 1 times 1, 1 times 1 times 1 is what? 1. Now plus, let's come to this place. What is x raised to power 1? Is x. X raised to power 1 is x. Is that also? What is 1 raised to power 1? 1. 1 raised to power 1 is 1. Then times 2. So 2 times x times 1. That would be what? 2 what? 2 what? 2x. X raised to power 1 is x. 1 raised to power 1 is 1. 1 times x, that is x. Times 2, 2x. Do you understand that? Now, plus, let's come to the third term. This is 1. What is 1 raised to power 0? Anything raised to power 0 is 1. Do you agree with that? Is that not so? Then what is x raised to power 2? X raised to power 2 is x raised to power 2. Is that not so? So x raised to power 2 times 1 will give you what? X squared. X raised to power 2 times 1 will give you what? Do you see that we get the same answer with this method that you are used to before? Is that not so? Can you see that we get the same answer? Do you see that? Okay. Now, this method is good when the highest power is 2, which we have confirmed by this. But the issue now is that what if the power is what? Exponent is what? 3. Is that clear? So that is where I'm going now. So that will take us to the next example that I'm going to do now, which I want you to pay attention to. Do you understand? Okay? Now look at this. If I say to expand this, expand 2x plus 5, for example, raised to power what? 3. If you write this as a plus b raised to power n, you see that here, if you compare this with this, a is 2x. Do you agree with that? B is 5. Do you agree with that? Then the exponent n is what? Is what? 3. So always reference this as this. Is that clear? Now, it means that the highest power is what? So I will now come here and use my Pascal triangle. I will create my Pascal triangle here until I get to the power of 3. Do you understand that? Pascal triangle. I will create it here. Now, look here. I will start again. You start with 1. Then you have 1, 1. Then you have 1 plus 1. 2, we end with 1. We are going to this when n is 0. This when n is 1. This when n is what? 2. So we are going to, when n is, then it ends with 1. So I have generated my coefficients. Hello? So this will be equal to, hey, look here. This now will be equal to, I'll write the coefficients. 1, you leave a space. 3, okay, let me just, plus 3, you leave space, plus another 3, you leave space, plus 1. You see that? Then in front, you put A and B. You put A and B. Let me space it so that it will be clear. You put A and what? B. You put A and what? Do you understand? In front of each of the coefficient. Do you understand the method? Now, you start from 3. This will be A raised to power what? 3. Then this will be 0 because 3 plus 0 is 3. It must not be more than 3. Is that not so? So this one will be reducing from 3 to go to what? This one from 0, it will go to what? This will keep on reducing. From 2, it will go to what? This one will be increasing. It will go to what? This one will be reducing. From 1, it will go to what? Then this one will go to what? If you see the exponent, 2 plus 1 is 3. 1 plus 2 is 3. 0 plus 3 is 3. 3 plus 0 is 3. Is that not so? That makes it balanced. Right? So this is equals to, look here, 1. What is A? 2x. Hello? You put the value there. So this is 2x raised to power 3. Our B is 5. You put 5 raised to power 0 plus this is 3. This is 2x raised to power 2. Our B is 5. This is 5 raised to power 1 plus 3. This is 2x raised to power 1. Then 5 raised to power 2. Then 2 plus this is 1. This is 2x raised to power 0. Then this is 5 raised to power 3. You just substitute. You replace it. You replace A, B appropriately here. Is that clear? Are you following? Now, this gives us. Now, look at this. Everything raised to power 0 is what? 1. This 5 raised to power 0 is 4. Is that not so? So this one is 1. Now look at this. 2x raised to power 3. 2x raised to power what? What does it mean? It means 2x times 2x times 2. How many 2 do we have there? What is 2 times 2? Times 2. That will be 8. You put dot there, that is times there. Then x times x times x, that will be x raised to power 3. Is that not so? Plus. Now this is 3 times, this dot means times. What is this? 2x squared. 2x raised to power 2. What does it mean? 2x times 2x. What is 2 times 2? 4. What is x times x? X squared. That will be 4x squared, right? Dot. What is 5 raised to power 1? That is 5. Then I put plus there. Look here. This is another 3. What is 2x raised to power 1? It means 2x. Just 1 2x. Is that not so? Times. What is 5 squared? 5 squared means 5 times 5. 5 times 5. What is that? 25. Plus. Now, look at this. The last one. This is 1. Dot. That dot means multiplication. Don't forget. Dot in mathematics means times. What is 2x raised to power 0? X raised to power 0 is what? 1. Dot. 5 raised to power 3. What is 5 raised to power 3? It means 5 times 5 times 5 times 5, 25. 25 times 5, 125. Now, let's now bring it together now. Look here. What is 1 times 8? 8. This will be 8x raised to power 3. Look at this one. Look at this. These are together. These are together. These are together. And these are together. Now, what is 3 times 4? 12. 12 times this 5, 60. Then we have x squared, 60x squared. Plus, what is 3 times 2? 6. 6 times 25. Look at it. 25 here times 6. 5 times 6 is 30. Remember 3. 2 times 6 is 12 plus 3. That would be 150. So 3 times 2 is 6. 6 times 25, that is 150. 150 times this x, 150x. Then we have plus. Look here. 1 times 1, 1. 1 times 125, 125. So the expansion of this gives us this. Did you see that? Did you see that? So with this, we have come to the end of this particular Class, you have seen how we use Pascal triangle to generate coefficient that assists in the coefficient generation while we are carrying out the expansion. So can you do the following for me? I want to give you some work to do. I want to give you just 2 problems to do for me, okay? Problem number 1, expand. Number 1, 3 plus x raised to power 3. Then number 2, 5x plus 1 raised to power 3. Maybe I should add another one. Okay, why not try this then? 2 minus x raised to power 4. Now, let me explain this one to you. If you have negative in between, this is what you do. If I say 2 minus x raised to power 4, and I need to write it as a plus b raised to power n. Okay? What we do is this. This one will be 2 plus, because there must still be plus. Then you put this minus x in small bracket like this. Then there will not be a bigger bracket like this. Do you understand that? Do you understand that?
Yes.
Okay, so with this now, your a is what? 2. Your b is minus what? Minus x. Then your n, which is the power, is what? 4. So it means that when you are creating your Pascal triangle, you will get to do it to the level of when n is equal to 4. Is that clear? So that you can write out the coefficient. This is an advanced aspect of algebraic expansion for junior secondary school 2. Like I said, I introduced this for the purpose of students that are preparing for junior Olympiad or that are preparing for cowbell examination. They want to find out if you can expand an algebraic expression that have a higher power from 2. Is that clear? So please keep subscribing, sharing, and supporting this particular platform. See you in another